Hello, today I'm going to talk about AES encryption modes. So I want to start by saying that if you see the first line, this is going to be a visual representation of other encryption modes. And the one over here in the form of a matrix is going to be AES encryption modes. Shortly, AES encryption mode is going to have the plain text, which we're going to XOR. We're going to substitute the bytes, shift the rows, mix the columns, add a round key. 128-bit key, we're going to have 10 times of this round. The bigger the key, the more rounds we're going to have. The two modes that I want to talk about AES is going to be the first one, CTR mode, and the second one is going to be the Galois counter mode. To go back right away on the first one, the CTR mode, I'm going to start right away with the code. So first, to do the encryption, we have to install AES, and we have to install PBKDF2. So after installing those on the Python, we import the libraries above and we start by creating a password. In my case, it's going to be hello there. And to add more security, we solve the password with a random 128-bit solve. After we've done this, we create the key. We print the encryption key. Just one reminder, we always have to store the salt. Otherwise, we cannot do the decryption later on. After creating the password, we basically have to just encrypt the text. This is the text that I just wrote for this purpose. The encryption is gonna take as a parameter the key and the counter, or the nonce, as also known. So after doing the ciphertext encryption, we basically print it, and this is gonna be our encrypted text. To do the decryption, it's pretty straightforward, as you can see. It's going to take two parameters, the key and the counter as well. We decrypt it using the AES decrypt, the CTR mode. And this is the text that we get back. So as you can see, it's the same one as the one above. Just one thing to keep in mind is that we cannot use a random key on the CTR mode. Otherwise, if I run this, we're going to have a wrong decryption, so it's not going to work. The other mode, also to give a graph representation. So as you can see, we start with counter 0 and we go to counter n. This is a nonce, or also known as IV. So this goes into the AES encryption with the key. Then whatever comes out, we XOR it with a plain text and we get a ciphertext. And this is going to go for every block of block that we have. To go on the other mode, which is going to be the Galois counter mode, this is a bit more complicated, and from what I read, in my opinion, it's way much more secure than the first one. So over here, we start with counter 1, we go to counter n, then we go through the AES encryption, we XOR it with our text, and we get the ciphertext. To add more security, we start with the counter 0, which goes into AES again, and we XOR with a hashing function, which adds that extra layer of security. Everything, as you can see, is going to be XOR with a hashing function. At the end, we're going to XOR the length with the hashing function, and it's going to give us the tag, which is what makes it different from the CTR encryption. To go to the code, which is pretty easy to understand. First of all, to run the code, we have to install the Crypto DOM, which I already have on my Python. So first thing that we do is that we create the secret key, which in this case is going to be random. As I mentioned, on the CTR mode, random key do not work. After doing this is going to be my random key. Then we do the encryption, which is going to get as a parameter the message and the secret key. We do the encryption using GCM mode, and in return, we're going to have a ciphertext, the nonce or the IV, and the tag. So this is going to be my message, which I want to be encrypted. We run the encryption mode using GCM, and we're going to print the ciphertext, the IV, and the authentication tag. If I go on, this is going to be ciphertext, the vector, and my tag. To do the decryption, it's pretty straightforward as well. We basically need two parameters, the encrypted message and the secret key. So we get the ciphertext, the nonce, the auto tag, which is going to give us the encrypted message. We run it, and we're going to return the plain text. And then we can just print the decrypted message, which is right over here. As we can see, it's going to be the same one. Basically, this is going to be two of the modes that two of the modes of the AES encryption mode that I chose to discuss today. Thank you.